Hello everyone, this is Manish here. So today what we are going to understand, we will understand thread in Java. We'll take up multi-threading and synchronization. So let's understand what exactly is a thread. So in Java, a thread is a single sequential flow of execution within a program. So threads are basically lightweighted subprocesses that can run concurrently with other threads, and it allows a program to perform various or multiple tasks simultaneously. So in Java, basically threads are instances from the already defined a thread class that we have it in the java.lang package. Okay, and it also either it can create an instance from the thread, or it can go ahead and implement the runnable interface that is also defined. Okay, so we can create and manage threads to perform various tasks concurrently, as I said, such as handling the user input, or processing the background task, or performing the parallel computations as well. Okay, so Java has built-in support for multi-threading. Okay, that we have it from the thread class. We'll see how the implementation goes. So in the respective code that you can see on my screen, we have basically a thread example. We are going to use it into four various ways. The first way is using the thread class. What we do is we have already defined a thread class. So I've defined a my thread over here. You can see this class. So this class is extending the thread class, and we have defined a run method. What this run method is going to do, it is going to initiate the number of, basically the run is going to initiate for all the iterations from 0 to 4, and it will go ahead and sleep. Basically thread.sleep means it will sleep for a second, and then it will keep on basically printing the respective thread. So this is what exactly happens whenever we are going to implement it using the thread class. Okay, now the second way which I was discussing is using the runnable interface. Now we'll see, I've created uh, one more operation to how to go ahead and create the runnable. So we'll see that what we are doing is, in this case, in thread 2 is equal to new thread, here we are creating a new instance for the runnable interface. Okay, so whenever we are going to create a runnable interface, as you can see my runnable over here which we have defined here, so we'll see that what it is going to do, it will call this, create an instance of this class, and it will implement the runnable. And the run that you see over here, it is also going to perform the similar operation, but this is going to be done for the thread 2, and it will again wait for 1 second and then print the respective threads. Okay, so this is the another way of implementing the respective thread in this case. Now let us see the third method of using the thread. In this case, we are going to use the lambda expression, where we are creating the thread 3 object on the thread basically 3 instance on the thread class. And what we are going to do is we are going to iterate over here and print the thread 3 iteration from loop from 0 to 4. Okay, it will wait for 1 second, and we'll give, so as you can see, to start the respective thread, we'll always give dot start. This is going to initiate your thread. So here we are going to start my third thread. Now talking about the fourth thread, which is the using the anonymous inner class, what we do is we create a runnable over here, interface over here, through the calling the respective runnable, and we are calling the run method over here to basically initiate the thread through the runnable interface. In this case, what we do is we are again starting over here. So this is basically going to start 4 threads. So we'll see the respective outcome over here. In this case, as you can see in my respective code, it is keeping on printing the respective for every 1 second. Okay, so all the 4 threads are concurrently working together. Now guys, let us look into the multi-threading concept. So what exactly multi-threading is, guys? Multi-threading in Java allows you to execute multiple threads concurrently and enables our program to perform multiple tasks simultaneously, and each thread runs independently, and our JVM, which is the Java Virtual Manager, manages their execution. So multi-threading is used for improving the performance, responsiveness, and the resource utilization in Java applications. So in the given code that you can see, what do you see, that I'm creating basically 2 thread on the thread class, my thread class that I've defined. So what is this my thread class? We have C and constructor that we are going to give a respective constructor name, and this is going to be initialized to the respective constructor name, and it is going to print the name and the respective value for the respective thread over here. Okay, so as my 2 threads are starting over here, so 2 calls will go, and both the threads I'm starting, and then I'm going to continuously print or monitor how these threads are going to execute, as we just saw in the last program. So in this case, 2 threads are going to work together, as we can see in the respective code. it is going to give main thread 0, thread 1, 2. It is going to print all the respective outcomes for all the iterations. Still, as you can see in the respective threads, even the main thread has been started. In this case, the other threads are overlapped to each other due to the thread dot sleep that we have used at instance. So it will sleep for 1 second, guys. Okay. So if you see, the 1 and 2 threads are going to sleep for 1 second. Accordingly, whenever we are going to invoke the run method over here. Also, just to add, guys, as we can see in our respective code inside the main method, we have created two threads, right? In my thread class, and we have assigned them the respective names. So what happens is that my main thread continues its execution concurrently with both the threads. And in this example, we are printing a message 5 times with a 1 second delay for each message. Okay. So that is how you are seeing the main thread iterating through the respective informations. Okay. So you can see that in the respective code that we have using two threads as concurrently in this case, which will increase the responsiveness and concurrent execution. So let us start with the synchronization. So what exactly is synchronization, guys? Synchronization in Java is a process of controlling to access the shared resources by multiple threads to avoid the data inconsistency and thread interface. So in multi-threaded application, when multiple threads try to access and modify shared resource simultaneously, it can lead to a race condition and data corruption. So synchronization ensures that only one thread can access a shared resource at a time, preventing such issues. So in my given example, as you can see, we have defined a synchronization example with the main method as at the entry point of the program. Inside main method, what we are doing is we created an instance of the counter class which represents on the shared resource. So this is what we are talking about. And in this case, as you can see, guys, so we are creative. What you're doing is we are creating two threads, thread 1 and thread 2 in our case, and both of which are initialized with an instance of the incremental task class. So both threads will increment the respective counters. So the counter class contains a method name increment. As you can see, it contains the method name increment, which is declared as synchronized, means only one thread can execute this method at a time. So inside this increment method, we are using a loop to increment the counter variable and print its value along with the current thread names. Okay, so we are also simulating some processing time with the thread dot sleep, which will give us some processing time as the respective thread is getting executed. Incremental task class that we see, it implements the runnable interface that we have just discussed. So in this case, what it is going to do is it will contain the reference to the counter object, and in its the run method that you see, it calls the increment method of the counter object. So when we'll run this program, we'll notice that our outcome is going to the threads are going to perform sequentially, as you can see. So in this case, the synchronization is so that the respective shared resource can only be accessed by one thread and not multiple at an instance. So this is about the synchronization, guys. I hope you guys are clear. In case if you have any doubt, please go ahead, comment on this video. If you really like the video, please go ahead to like, share and subscribe this channel.